Good morning. Welcome to the webinar. My name is David Simpson. I will be your host for the next few minutes, or close to an hour, I suppose. And the topic today is static SQL on DB2 ZOS. So thanks for tuning in. This webinar is a little bit different than some of the topics that I have presented here in the past. It's a little more of a beginner topic. And when I say beginner, it's just kind of basic to the way we operate with SQL that runs natively on the mainframe usually. But I find it's a topic that there's still a lot of confusion on. And actually, I had a few people ask me recently, what class should I take if I just want to understand packages and plans and collections and how all of that stuff works. And we do have this stuff embedded in some of our classes, but I thought it was a good topic that would make for a good 45-minute webinar or so. So I put this together over the last few weeks, and hopefully you'll find it helpful. Hopefully those of you who already do have a firm grasp on this stuff can share this with your colleagues that don't. So thanks for tuning in. You've got my email address on the screen there. Again, my name is David Simpson. You can always reach me at that email address. You can follow us on Twitter. That's a great way to get in touch with me. I don't mind interacting with you guys at all. It's one of the ways I stay in touch with what goes on in the real world. I've talked about me in the past and what my background and experience is on past webinars. So you can, if you want to know more about me, you can go back and look at some of the replays on that. The replay for this one will be available either later today or maybe tomorrow. So if you want to share this with friends and colleagues, you'll be able to do that. The link for that is down at the bottom here, www.themisinc.com/webinars, themisinc.com/webinars, and you can use that link both to look at the replay of this webinar later. You'll see the other webinars that we've done over the last couple of years. We've been trying to do about one a month on various topics, some of them DB2, some of them Oracle. We've got a lot of a couple of MQ topics out there, and a few Java ones as well. So we've kind of covered the spectrum of the kinds of classes that we teach, and you can get little samples of what we teach and what it looks like, and take away a little bit of free information from these webinars. As I said, we've been doing them for about 2 years at about a clip of about one a month, so there's a bunch of them out there now. Also, if you'd like to get the slides for today's webinar, they are also already out there right now. Again, the link is themisinc.com/webinars, and right at the top you will see a slot where the replay for this is going to go, and you can download the slides right now, even if you'd like to follow along. So please take advantage of that. A little bit word from our sponsor. Themis Education is the company that I work for. We teach classes, right? Some of our offerings are kind of listed at the top there. Do a lot of DB2, a lot of Oracle, Java, and the mainframe is one of our kind of areas of core competence, and with a specific emphasis on DB2. So if you check out the rest of our website there, which you can get to from that link as well, you'll see an awful lot of our offerings. One of the things you will see on our website is our public schedule, which I will show you a couple of things I want to highlight there in just a minute. But also be aware if you've got a large enough group at your site that we can come to you as well. We also do a lot of distance learning on the public schedule especially. So we've got a lot of options for how you can get trained now. And if you have more questions about that, you can feel free to contact me offline. We have A couple of classes coming up that I wanted to make you aware of. Starting actually next week, we have both of our beginning and advanced cross-platform SQL being offered next week in the distance learning environment. All of these that you're seeing here are guaranteed to run by the end of the year on these dates. So we also have some more DB2 specific SQL classes on December 12th specifically, and November 29th we've got the performance and tuning, DB2 SQL performance and tuning. So all of these are all ready to go. They're all offered via distance learning, meaning it'll be a live instructor, but you can take it from really anywhere in the world in the comfort of your home. So again, if you want to check out the website, you'll see more about all of these and other classes. If you have specific questions, you can feel free to use my email address to get to me. I will put the email address back up on the board at the end of the webinar in case you didn't have a chance to get it a couple of minutes ago. So the topic today is static SQL, right? Static SQL on DB2 for ZOS specifically. The mainframe is a little unique in this area because we are used to static SQL as being kind of the default because of our mainframe heritage, because most of the applications that we supported 15 and 20 years ago on the mainframe were written in COBOL. COBOL lends itself very nicely to the use of static SQL. On other platforms, if you go to Oracle or SQL Server or even DB2 on Linux, Unix, and Windows, those folks are a little bit more used to dynamic SQL as being the default. Well, what's the difference between the two? Static SQL is SQL that we have coded in a program. We have delimited it, right, to separate it from the rest of our application code. And in COBOL, we delimit it with the exec SQL and exec delimiters. So everything in between those delimiters is SQL and not COBOL. And we then send it through a precompiler, right? And the precompiler actually pulls out the SQL, rewrites it essentially as COBOL, and then deals with it separately. Dynamic SQL is an SQL statement that you send off to DB2 dynamically from your program. And this is typically done, and this can be done in COBOL, but in this day and age, it's more commonly done by things like Java or .NET or off-platform, off the mainframe, things that are connecting up to DB2 to do something, and they send it an SQL statement and it runs. The major difference there is static SQL is known to DB2 ahead of runtime. We've pre-processed it and compiled it even, if you will, or bound it in DB2 terms. Where dynamic SQL is DB2 doesn't necessarily know about it till it shows up and tries to run. So dynamic SQL, you're typically building a variable in your program that has a SQL statement in it, and then somehow, depending on which platform you're using, sending that up to DB2 and saying, hey, run this. Okay, so we're going to focus today on static SQL, and with the assumption that you're using things like COBOL to run static SQL. On other platforms, the main way we get static SQL is by stored procedures, and that's also a fairly common thing to do on the mainframe as well. So if you have a Java program that is connecting up to DB2 to run some things, then if you want that to be static SQL, one of the main ways we would do that is by calling a stored procedure where this same process comes into play that we're about to talk about. The slide that we have in front of us here is one that when I was fairly new to DB2, going back to about 1993 or 4, somebody drew this on a paper napkin for me to explain it. And I have drawn the same picture on paper napkins for others countless times since. And when I started teaching, we made a slide out of it, so I didn't have to sketch it on the paper napkin anymore. But this is the compile process or the program preparation process for something like COBOL, and I'm going to use COBOL a lot as the example, but keep in mind there's lots of languages that support static SQL on the mainframe, things like PL1 or even C or C++, assembler, lots of languages we can use on that mainframe that all support static SQL in this same way. Right, so you'll see a couple of examples coming up that are COBOL, but just keep in mind it could be really any of those languages that are native to the mainframe and support and have a precompiler supported by DB2. So up at the top there we see our source code, right? The source code coming in to my program right up here. So that's a module that or a text file essentially that has your COBOL source code in it, and then mixed into that source code is SQL. And we've delimited and tagged the SQL with that exec SQL delimiter. We also could have declgens, and declgens are nothing more than copybooks, usually describing the tables in COBOL terms that are going to be used by this program. And both of these things come into a process called the precompile. So the precompile's function in life is to separate the SQL from the COBOL. Right? And COBOL goes off to the left and SQL goes off to the right. The module coming out to the left there, we call that the modified source. And usually in your JCL, that'll actually be a temporary data set. In other words, we don't keep that. It's just the COBOL code scrubbed of its SQL, ready to go into the compiler. Out the other side of that, we get the SQL, and it goes into a module called a database request module. Again, it's just a text file coming out of your precompiler. Database request module, if you look inside that, it's just showing you your SQL. It's just your SQL. And that SQL is parsed and tagged, and it's not pretty. And beginning about in version 8, it's in Unicode. So if you're looking at it with your editor or browsing it on the mainframe, you're not even going to be able to read it anymore because we usually look at things in EBCDIC on the mainframe. But at its core, it's just the text of your SQL. It's not a executable on its own. It's just got your SQL extracted from the program and parsed and tagged and put in a format that the bind process can read. On the left side there, your COBOL stuff goes through a compile and link edit, and you get a load module just like you had compiled any COBOL program before. On the right side, your DBRM or your SQL goes through a process called bind. And a bind produces a package or plan, and beginning in version 10, your really only choice was package. And that package is, you can think about it like the compiled SQL or the executable stuff, the stuff DB2 needs to actually run that SQL at runtime. So all of this happens ahead of runtime, right? It's part of the program preparation or compile. And out of the bottom here now, my application or my program is split into two pieces. I got the COBOL stuff and the SQL stuff. And the COBOL stuff is in a load module. The SQL stuff is in a package or plan, which is stored actually inside of DB2. So that package is not something that spits out into like an output data set, but it's actually stored internally inside DB2. So because my application is now split into two pieces, at runtime I'm going to have some way to get them back together. In other words, when my program is running COBOL stuff, I'm over here, and then it does its first call to an SQL statement, and we're going to have to go find this package to run the stuff that makes up that SQL. So the way DB2 keeps track of all of this is that the precompiler generates what we call a consistency token. That consistency token, you can think of it like a timestamp that is placed actually in the modified source and in the DBRM and carried through down to the bottom. that consistency token, it's actually just a big, a hex thing. But you can think of it like a timestamp. It's generated by the precompiler. So DB2 will be able to determine at runtime that we have appropriately matched up the load module with the package that we're running. All right, so this is going to become really important later when you're trying to debug that whole -805 SQL code thing. That's everybody's favorite SQL message, right? All right, so that consistency token we're going to come back to later. But this is the guts of our program preparation, and most of this stuff is usually found, in a proc that you execute. In other words, you change the source module for the program that you want to compile, and then you type sub, and all of this stuff comes out. When I teach new DB2 developers, I often ask them, what's a bind? How would you define a bind? And the most common answer I get is, well, it's the last step of my proc. I know I got to have it. I know that if I don't get it right, then bad things happen when I try and run the program. But a lot of people are not too terribly interested in figuring out what goes on in there. So that's what we want to talk about today is, this whole the bind process and what gets produced and what happens when I screw it up. So let's go ahead and take a look at some of the steps that are in this proc and see what we can find. Now, as I said, usually compiles are done in JCL procs. This one I actually broke out into a set of steps in JCL without using the proc so that we can see what all the steps actually do. What you're seeing here is the JCL for the precompiler, that precompile step. It's actually a module in DB2 called DSN HPC for the precompiler. And you see we got a bunch of params we send in. We tell it what language we're using and a bunch of options that we'll talk about a couple of those in just a second. We also have a bunch of files coming and going here that we should probably look at. So things like, there's my source code. There's a DD in the precompiler called sysin, and I've got a partition data set there that has a member called LOTSA SQ1. Okay, so that is a COBOL program source code, and again, that COBOL program has COBOL in it, and it's got a bunch of delimited SQL statements in it as well. So that's my source code. We're also going to have an input library for declgens. Right? Again, so this is copybooks. Right? The difference between these is for those of you who are COBOL developers, you can bring copybooks into a DB2 program one of two ways. You could say exec SQL include, and that is what's going to be brought in here. Or you could just say copy, a regular old COBOL copy. The main difference is where is it going to be brought in? Is it going to be brought in by the precompiler, or is it going to be brought in by the compiler? Certain ones we're going to need, the precompiler needs access to. Your declgens are needed by the precompiler, right, in order to determine what your tables look like. So if the precompiler is going to need to see it, then you better do an exec SQL include, and it'll pull it out of this library right here. Or you could concatenate other libraries in here as well. So my declgens, my includes are going to come out of a library, in this case called themis.declgen. It's another important distinction to make here is that the precompiler itself does not talk to a particular DB2 subsystem. We can run the precompiler even if DB2 is not up and running. The precompile does not connect to DB2. The only thing it knows about your tables is what you tell it. And the way we tell it about the tables that are being used is via these declgens. So a declgen has two pieces to it, and it's got a description of the table in DB2 terms, and then it's got a description of the table in COBOL terms. And it's got variables, right, COBOL data structures that contain COBOL variables for each of the columns on your table. Okay. So DB2 doesn't know anything about the actual tables, or I'm sorry, the precompiler, I should say, does not know anything about the actual tables that you've got defined in DB2, and it actually doesn't care, and the precompiler is actually not concerned about any particular DB2 subsystem. So I can take what comes out of this and bind it against my test DB2 subsystem or my production DB2 subsystem or any other DB2 subsystem that has the tables that we're describing here. So the precompiler does not connect to DB2, and what comes out of it could actually be bound to multiple DB2 systems. So the declarations and the source code come in, and then what comes out? Well, this syscin is the DD that's going to have the modified source going out to the compiler. And as I mentioned before, that's usually a temporary data set. So that's what the ampersand DSNH out. If the compile is just the next step in this JCL stream, we'll just take this temporary data set in, and there's no real need to preserve it. Right? It can easily be generated again by running the precompile again. You want to keep your source code and you want to keep the load module that comes out, but I don't really need this modified source member. This is just going to be what goes into the compiler. We'll actually see a small sample of what that looks like in a moment. All right, and then we have one other output from the precompiler, and that is the DBRM. All right, so I've got a DBRM member, all right, themis.db2.dbrm lib, and then my member name is LATSA-SQ1, the name of the program. So that is going to be where that database request module or DBRM goes. And remember, the DBRM is just the SQL that was extracted out of this source code. So we got two inputs really and two outputs. Declarations and source code come in, DBRMs and modified source go out. Modified source goes to the compiler. The DBRM goes off to the process called bind. Right. Now, another thing we should look at on the precompile is this version. A lot of confusion about versioning, and I'm going to try and talk about it a little bit in a moment. But this version auto parameter going into the precompile is what asks DB2 to please version the package that's going to be resulting from this when I do the bind. If I don't have this, then versioning will be off. And all that means is I'm only going to have one copy of this program in a particular collection in DB2 at a time. If versioning is on, and in this case we're saying DB2 automatically generate the version ID, then every bind that I do that comes out, if I compile this program 5 times, I'll generate 5 different versions and therefore 5 different packages. Even if in other words, when I do the bind, the subsequent binds will not overlay the ones that are already there. When I was first trying to figure out versioning, I was looking in the bind for bind options related to this version, and that's not where you find them. You actually find it all the way back up at the precompile. So another way to say this is a DBRM coming out of this is versioned, and therefore any packages that are created from the DBRM produced will be versioned. And we'll talk a little bit more about what that means in a moment. Okay. You can see a little bit about what the modified source does. So in my source code, in the middle here, you see I have exec.sql and I'm doing a select into. And what comes out of the modified source is actually, you'll actually see this code, the exec.sql. If you were to look at that modified source member that was the temporary data set, or if you just look at your COBOL compile listing coming out of the compiler, you will actually see that the exec.sql stuff commented out. It doesn't remove it, but it just comments it out for the COBOL compiler. In other words, the COBOL compiler does not understand how to deal with this. right, that SQL. Now, there's a small exception to that. Some of the shops I work with have actually used the integrated precompiler. In other words, there's flavors of the compiler now that you can use that have the precompiler kind of integrated into it. So it's one step instead of two. That was introduced, probably over 10 years ago. And I don't see a ton of people using it, although I do have a couple of shops that I work with that use that integrated compiler. But most shops still go through the precompile, compile, link, edit, bind process. If you look at that modified source, you'll see the SQL actually commented out, and it will translate it into calls to this module called DSN-HLI. DSN-HLI is actually a routine supplied by DB2, by IBM, and that's where it's actually going to do, the result of this SQL. It's actually going to go find that package in DB2, or look for it anyway, and execute it. And you notice that it has a whole structure of things that it passes in and out of DSN-HLI. So basically it's going to be saying, please run this program with this consistency token and this statement number. So every statement coming out of the precompile will be tagged with a number, and if you don't override it, that number will be taken from the line number in the precompile listing. So in other words, a statement beginning on line number 72 will be statement number 72, and when we run it at runtime, it's going to be calling this DSN-HLI saying, this program, this consistency token, run statement 72. Okay. So DSN-HLI is calls to a DB2 module, and the actual module that's going to be run under the covers actually depends on how we link edit this thing at runtime. But this is how DB2 is actually going to deal with this at runtime. Go find the package, well, call a module that DB2 supplies. And you see some other generated code down here. This is if you use a whenever statement, the stuff at the bottom. Oops. Sorry about that. I blanked the screen out for a second. I don't see a ton of people use a whenever. It's just kind of a way to cheat with error handling. But if you use the whenever statement, DB2 will also generate this kind of default error checking down at the bottom. Okay. All right, so let's take a look at the bind. So here is a sample bind. You notice that the input to the bind is going to be that same DBRM library that we were looking at before, right? That came out of the precompiler. The bind control card itself is a little bit confusing to me. Now notice here we are, and I don't have a pointer at this, but we are talking about a particular DB2 system here. So while the precompiler did not attach itself to any particular DB2, the bind process does. You can think about the bind is it's taking the DBRM at that database request module, has the SQL for a single COBOL program, and it is binding it to a particular DB2 and a particular set of tables on that DB2 system. So the precompiler doesn't know for sure what my tables look like. The bind does. So if you spell a column name wrong, if you say, select last name and you spell last name wrong in your source code, you might get a warning out of the precompiler like, yeah, you didn't tell me that about any tables that had that column name. But the precompiler doesn't really know what that table looks like. The bind does. So if you spell things wrong, the bind is where you'll get the hard errors saying, yeah, that column doesn't exist or that table doesn't exist. So a lot of your hard errors actually come out of the bind process. So here we're telling it, I'm going to bind this package on a DB2 subsystem called DB1A, and then the collection, this is where the syntax gets a little bit confusing for me anyway. I say bind package, and I'm expecting to put a package name in those brackets, but you actually put the collection ID. Now we're going to talk about what a collection is in just a second. For now, think of it just like a place to put the package. A collection in DB2 is kind of like your load library where your actual load modules live. It's just when you compile it, you got to put it somewhere. So a collection is an object in DB2. It literally is a collection of packages. It's just a place to put the package. The member name is the actual name of the program or module that I'm binding. So I'm going to take a program or a DBRM called LOTSA-SQ1 and bind it and put it in a collection called Themis CL in this case. The DBRM library, so this program called LOTSA-SQ1, the DBRM is going to be searched for in this DBRM library up top here. And again, you could have multiple libraries concatenated. Typically, this one, you'll only have one. Right? So take a package called LOTSA-SQ1, bind it to a collection called Themis CL on DB2 subsystem DB1A. That's what this is going to end up looking like. Okay. Now, there's a bunch of other bind options. I'm going to point out some of the more important ones here. The qualifier. Okay, the qualifier says, what set of tables are we going to use? So on DB2 system DB1A, we may actually have several different copies of the same tables. This is particularly true in test environments. Right? We may have one copy for unit testing and one copy for integration testing and another copy for quality assurance. You've got how many different levels of tests do you have, and some of those share, in the shops I've been in anyway, some of those share the same DB2 subsystems. So the qualifier on the bind says any unqualified table references in the program will be qualified by Themis 82. Now you can hard code qualifiers in your code and that'll override this. But the common practice here is to leave your table references in the program unqualified. So in other words, I don't say select from themis82.emp, I say select from emp, the short table name, and then at bind time, DB2 resolves those references. And that means that I can bind it against my unit test tables today and then take the same DBRM and bind it against my integration test tomorrow and user acceptance test the next day or whatever, right? I don't have to decide which particular set of tables I want to go at until I do the bind. Right, so that's the qualifier, and that's one that you'll see used in almost every bind card that gets written. Another one that's sort of interesting is the owner of the package. That has to do with authorizations. So one of the great things about static SQL is that we have a lot of control over authorization. The people running this program, so a user comes along and subs a batch job that runs this program, that person does not need to be authorized to do all the SQL in the program. What they need is authorization to execute this package. This owner ID here, this is the credentials that are going to be used to actually validate the SQL in that package. So this owner needs quite a bit of authority. The owner needs, and that is also tied to this other bind option called validate bind, which is usually what we want. Okay, validate run says don't do all that checking until runtime. Okay, but the owner needs to be authorized to bind a package, and the owner needs to be authorized to put the package in the collection we're talking about here, and the owner needs to be authorized to do all the SQL that's in the package. So the owner on a bind has to be a fairly authorized individual, and it can be a person's user ID who's submitting the bind, or it can be a secondary auth ID that whoever is actually submitting the bind is attached to. So in other words, your DBAs may grant authority not to you individually, but to a group that you're in. If they grant it to a group, then you have to stick that group ID in this owner. Okay. Now you see a bunch of other bind options there that we're probably not going to talk about today, but I'm giving you the link here. Don't try and type that into your browser, but if you download the slides from the website that I showed you a moment ago, you can click the hyperlink. If you were not here for the beginning and don't know the link I'm talking about, I'll put it on the screen again at the end. It's themisinc.com/webinars. You can download these slides and then get to the hyperlinks inside it. Okay, so lots of bind options. The documentation tells you about what they all are and what they do. Basically controlling the behavior of this package when we run it. Okay. Now versioning, so we said a collection is a place to put a package. Right, so if you look at my query here, I'm just going out to the DB2 catalog to a place called sysIBM syspackage. And I'm saying I want to see all of the packages in collection called Themis CL, where the package name is LOTSA SQ1. And you actually see 5 of them here, which is really interesting. Right? You can't do this in a load library. I said a collection is a little bit like a load library. Well, this is actually a little bit more flexible than a load library, right? A load library can only have one copy of a program at a time. But a collection actually can contain multiple versions. Now remember, this goes all the way back to the precompile where I said version auto. That is what made these DBRMs bind actually separate copies of this package or separate versions of this package every time I ran the compile. You see that version ID, if you use version auto in the precompiler, it just takes the precompile timestamp and makes that the version ID. So you can tell a little bit of something about when this thing was compiled by looking at its version. And then you see the bind time. So a lot of people wonder, well, what's the difference? You know, why would I have a different bind time than a version ID? And in most of mine, you can see they're pretty close. You see, like, let's take this third one. It was, the version is November 6th, a few days ago, at 3:08:36. Right, 3:08:36. I think that's actually UTC or Greenwich Mean Time. So it standardizes the clock. You actually see the bind time. The bind time is represented in local time. So if me here in North America, I'm a few hours behind UTC. Right, so actually it's a different day, right? The version is the 6th. The bind, it actually was bound before it was versioned. That's interesting, and that's because of the UTC thing. Okay. You see that first copy there, though, that was versioned on the 6th wasn't actually bound till the 7th. Well, that can be for a few reasons. Number one, I could take that DBRM and bind it again, or I could do a rebind, which we're going to talk about a little bit later. All right. So you see I've got multiple versions of this package. Now when I run the program from the load library, what is it going to do? Which one of these am I running? Well, that's going to be determined by this consistency token that we talked about a little bit earlier. So the consistency token is another thing that's in this package that we're seeing here. And you see in my query, I've actually used the hex function in SQL to kind of unpack it. You know, show it to me as something I can read rather than just unprintable characters. And you see that consistency token is different for each of these versions. That is the thing that was generated by the precompile that's going to be used to match up which one of these I'm going to run. So in other words, if I run a load module that has a consistency token of this whole thing ending in 931, well then which version of this package am I running? I'm running the middle one there, the third one. If I send in a different load module and run it, you know, with a load module that contains the consistency token ending in DE4, then I'm going to be running that last one. This is pretty cool, actually. Versioning allows you to be really flexible with change control. Number one, it means that I can roll this thing out before I'm ready to actually run it. I can do the bind whenever I want. It also means that I can fall back pretty easily. So in other words, and I know this never happens at any of your shops, but where I've worked in the past, we've put new code into production and then found out that we didn't really want it there and had to back it out. If you've made a backup of your load library from before the deploy, all you got to do is substitute that load library with the old load module in it. If your packages are versioned, The old one is still there, and it'll just start running that one when you send in the old load library. Okay, so versioning is a change control technique. That means I can stage code before I'm ready to run it, and it means I can fall back pretty easily without recompiling. If you're not using versioning, then you're going to have to go find, either recompile the old source code or go find the old DBRM and bind it again. So this simplifies your change control quite a bit if you use versioning. I'd say probably half the shops that I visit now still don't use versioning. It requires just a little bit more planning and knowledge of what's going on inside here. And it also requires you to do a little bit of your own cleanup, because DB2 never purges out old versions automatically. So in other words, if this program is 20 years old and it's been compiled 100 times in that course of that 20 years, you could have a lot of versions of it out there. So in the shops I've been in that use versioning, we typically wrote some homegrown thing to identify, maybe we keep the last 3 or 4 or 5 versions of a program. You probably need to keep more in test than you do in production, because people are compiling all day, every day in test. But in production, if you keep the last few, you're probably good. But you are on your own to kind of clean up old versions. So that is one kind of downside of versioning. It requires a little bit more planning and cleanup on your part. But it also provides you a ton of flexibility with the way you handle change control. Okay. All right, so let's kind of talk about these other pieces of terminology that I've been dancing around a little bit. So location is just simply a DB2 system, right? Within a DB2 system, in my case, the location was DB1A. That's the DB2 I was connecting to. A collection, again, when I do a bind of a package, a collection is simply a place where the package is going to live. Right? It's a home for the package. A package is just one single, the DB2 executable stuff for a single COBOL module is a package. A plan, well, and we just talked about versioning. A plan is going to be the thing that we need to reference at runtime. Now, we haven't talked about plans yet. So let me back up and just a little tiny bit of history. You can't even do this anymore. But in the old days, and we're talking about late 80s, early 90s, your only option when you were going to run an application, when you actually, run a program, and I'll skip forward a few slides and show you what that looks like. Okay, when I run a program here, so here I'm running my program called lots of SQ1, I give it a plan. I don't tell it where the package is. Specifically, I give it a plan. In the old days, that plan was one big giant module inside DB2 that contained all of the SQL for everything I might call. So not just for this module, but if my COBOL program called lots of SQ1 makes a call to another module, my plan would need to contain them both directly. And another way of saying that is, if you had an application that was made up of 50 modules and you recompiled program 27, the bind would have to bring in all 50 DBRMs, meaning the one that changed plus the 49 that didn't, and we'd have to bind it all again together. So a plan is like not a modular way of doing things, but it is still what I point at runtime. Now these days, and beginning in version 10, that environment went away, and they said we have to start using packages. Packages are just a more modular way of dealing with programs. In other words, I bind a single program into a package. I still need a plan though. What a plan looks like today, you can see down here, we've got an example of a bind plan. This is something that a DBA probably does once and then leaves alone. I'm saying I've got a plan here called Plan Z, And a plan today, rather than including DBRMs directly, will include a package list, PK list. And what I'm saying here is that the plan called Plan Z contains all of the packages that are in collection X. Now, I'm doing this with a wildcard in that first example, collectionx.everything, which is the way I like to do it. We could get more granular than that, though. In this second example, I'm saying Plan Z only contains these 3 packages. So there may be other packages in a collection called Collection X, but this plan only looks at these 3. A plan could also contain stuff from more than one collection. So here I've got a more sophisticated plan list or package list. I'm binding my plan. It's still called Plan Z. The package list is all of the packages in Collection 1 and all of the packages in Collection 2 that begin with the letter P. You can think of a plan at runtime as a step lib, sort of, for the packages. In other words, a step lib in your JCL, when you're looking for load modules, you say, look here first, then look there, then look the 3rd place, then look the 4th place, right? It's going to search each of those libraries in your step lib until it finds, the program that you're looking to run. A plan in DB2 terms now with a package list does exactly the same thing. When I run a program and I point it at Plan Z, it's going to search for the package that I'm looking for in Collection 1 first. It'll look for all the packages in Collection 1. If it doesn't find it there, it's going to look in Collection 2, but only the things that start with P. And if it doesn't find it there, I'm going to get a -805. But it's just a search order when looking for packages. Okay. So you can think of a plan as it's just directing traffic, right? The plan doesn't contain actual executable code anymore. It just contains lists of places to look for that actual executable code. Okay. So here I've got an example of an output of a bind package on the left. And on the right, you have the output of a bind plan that includes a package list. So this particular plan says all of the packages in a collection called Themis CL. So a package is one module, a collection is a grouping of packages, and a plan is a search list, essentially a package list. What collections do I look in at runtime to find my program? Now, as a practical matter, most of the plans that I see are bound with collection.asterisk, meaning all of the packages in this collection. And by the way, it's not just the packages that are in that collection when I bind the plan, but all of them that are there now and will ever be there. All right. We talked about the qualifier a little bit, right? If I say select from employee in my program, which employee table, tables have 2-part names within a subsystem, right? Which employee table am I talking about there? Well, it depends on how I bind the package. If I bind the package with a qualifier of test, then I'm going to be selecting from test.employee. If I bind the package with a qualifier of prod, then I'll be selecting from prod employee. This is very good. It's very good to leave your SQL unqualified in applications. It means that I don't have to change the code when I go from my unit test to user acceptance test, quality assurance to production. Right? All I'm doing is changing the qualifier on the bind and binding it in a new place. Debugging, and when I teach this in a class environment, we actually spend a little bit of time in workshop looking at this. But the output messages from the bind are not necessarily, the most friendly. So when we get an error on the bind, all you're going to see is that thing at the bottom, right? And don't let this message right here fool you. Using ODY ED authority. Sometimes people see that as, well, that's my error. That message actually comes out in every bind. It's just letting you know, hey, that was the owner ID that you put on the bind. This is the person's authority that I'm using. That is not the real error here. The real error is an SQL code -206. And if you look that one up in the book, or use QuickRef, a lot of you have QuickRef probably, but if you look that one up in the book, you're going to see a message something like, column not found. Right? Have a nice day, right? So if this program has 50 SQL statements in it, well, how do I know which one? It gives you a statement number here, statement number 99. And remember how I said it assigns that statement number based on the line number in the precompile listing where that statement occurred. So this is how I match up. I got a -206 at statement 99. You got to go back to your precompile listing and you'll see the actual statement. And it gives you a little bit of an idea of what is the problem, right? What did it not like? And if you look at this, I think you see probably the problem, or some of you notice the problem, that WS department is a COBOL host variable. I forgot to put a colon in front of it in this case. Because I didn't put a colon in front of it, the bind process treated it as if it were a column on the table. And because that column is not found, I get the -206. Okay. You see also the precompiler up at the top flagged that as a warning, and you probably got a condition code 4 out of the precompile, meaning, yeah, this doesn't look quite right, but whatever. The bind will figure it out. Right, so the bind is what actually gave you the hard error, and the bind actually fails. So this is kind of important to know. You need a bunch of pieces to put together. You need to know what the SQL code means, either quick ref it or look it up in the book, and the statement number, go back to the precompiler to find out where the problem actually was. One quick word on bind versus rebind. The bind process takes in a DBRM and produces a package. Okay. Rebind is another command in DB2, not so much used by developers, but I think it's important to understand the distinction. A rebind does not take in a new DBRM. A rebind just takes in the statements that are already in the package and rethinks them. So when do I bind? Well, I bind when I have a new DBRM. Right? We've compiled the program again. And I got a new DBRM and now I want to bind it. Or I'm pushing the program up to production or next level of test. We move the load module over there. I'm going to have to move the DBRM and bind it. Rebind I will do when the code didn't change, but I just want DB2 to rethink the statements. So if we add an index or something, or we run stats, or the DBA makes some change to the environment, they drop and recreate a table that invalidates the package. Rebind just says the code didn't change, the SQL didn't change, the consistency token didn't change. I just want DB2 to rethink this package. Okay, so rebind and bind are not the same. It's important to understand, to at least have some idea of what the difference is. When I recompile a program, I have to bind, not rebind, and that's a little bit funky in the messaging. All right, when I run the program, we looked at this already. Here I'm using the TSO monitor to run the program. This is one way of running a program in batch. There are other ways. This way is really common though. I'm running the program called lotsasq1, and I don't tell it where the package is directly. I tell it what plan I want to use. And remember, the plan then will search its package list until it finds a program with that name and a consistency token that is the same as the one in that program. And remember, I had multiple versions. I'm not specifying a version ID here. It'll run whichever one matches this load module. All right, one quick word about -805, and then I'm going to be done. -805 is, every developer's favorite SQL code, I think. It means that when I ran the load module, DB2 was not able to find the appropriate package. Okay, so when I get to the first SQL call in my program, the package list in my plan, Themis PL, will be searched for a matching package. Consistency token is used to find the match. If I don't find it, I get a -805. So, and this tells you, right, here's the program I was trying to run, and this is the consistency token I was looking for, and it spans the line, right? 1A3354 Fox 1 3 Echo Fox Charlie 029. That is the consistency token it was looking for. If you want to figure out why it wasn't finding that, you can go out to the DB2 catalog and look for a package with that consistency token and see if it's there. Okay, so it's kind enough to tell you this is the consistency token that was in the load module. and I wasn't finding a package with that same token. And on this last slide here, I've given you some common reasons why you get the -805. Your compile worked, but the bind failed, right? Didn't get a package. So I have a load module, but no package. If you try and run the load module, it's not going to find it. A bind succeeded, but you put the package in a collection that's not in your plan. So I can bind the bind could work, but if I put it in the wrong place, then DB2 is not going to find it. Did I bind to the wrong DB2 subsystem? Am I running with the wrong plan? Am I running with the wrong load library that maybe has an old copy of the program that isn't matching up to any current package in my package list? If versioning is not used, then somebody else ran a bind and overlaid your package. So if you're versioning, somebody else running a bind in your collection is not going to hurt you because it doesn't overlay, right? We just add another version. If versioning is not being used, then every time we bind, we're overlaying the same copy of the package. This is particularly problematic in test environments where we're trying to share a collection with other people. You really need versioning in that case. Otherwise, you're not going to be able to play nice with others. Okay, so these are just some common reasons why you get that -805. Just keep in mind, it's just going through the package list in the plan and looking for a matching package. It has to match the package name and the consistency token in order to be a match. Right. So that's what I got. I got my email address up on the board as we wrap up here. If you have any questions or comments, you can feel free to email me, dsimpson@themisinc.com. I also would direct you to our website. That is www.themisinc.com/webinars. If you would like to download the slides from this presentation, look at the other webinars that we've done, and then as I said earlier, within a day or so, we will also have the replay of this webinar out there. So if you found it helpful, or if you have friends that might benefit from seeing this, you can direct them. Again, www.themisinc.com/webinars is the address. So thanks for spending part of your day with me. Again, please feel free to contact me if you have any questions or comments, and enjoy the rest of your day.